So first off, Tech Talk. It's just, if you want to do one yourself, you can. It's just about any tech-related thing you find interesting. It's kind of like a bite session, except with legacy and heritage. So anyways, so mine is about functional programming for non-functional languages, or how I stopped using loops and learned to love the lambda. So without further ado, so this is some JavaScript code, and it's got this function called parse data, which is intentionally poorly named. So I want if you would like, to give your guess as to what this function does really quick.
Does it parse data?
It does do that, but I'm more specific. Like, what would it return? And all right, so this is basically what I expected. And the point of this is that this does not communicate very well what it's doing. And I would say the main reason for that is because it's using 3 for loops. And for loops are fine, they're very simple, and everyone knows how to use them. But they also don't really, there's like a number of problems with them. And one of them is that they don't convey what they're doing very well. And they introduce some complexity because they introduce a new variable and a mutable variable. So you kind of have to be like, what's this I doing? Like this I, and it's pretty simple. It's just looping through all like the length of the data array. But in this one, it's like it's going backwards, and it's kind of janky. But what this function is actually doing is that first it's filtering out. So it's taking in this data, and it's filtering out the strings that have non-numeric characters in it using this regular expression. And then after that, it's just going to parse them all into integers. And then after that, it's going to multiply all of them together to get the product. And this function, I guess, it's fine in the sense that it works. Like, I'll show you, and I'll also bump this up. So that's what it does. It just takes all this, filters out all the unnecessary stuff, so like all the stuff that has non-numeric characters, and then multiplies it all together. And what we're going to do really quick is we're going to rewrite this, but instead of using for loops, we're going to use kind of more of a functional approach. And we're going to use filter, map, and reduce / fold. But in most languages it's called reduce, but in most functional languages it's called fold. But we'll get into what those are later. So firstly, we're going to create a new function called parse data2, like so. And I'll just copy and paste the whole thing here. We can. Oh yeah, would any of you want to like follow along? Because I can post this code in the Discord if you'd like.
I'd love to.
Okay, cool. Let's redo that then. I'll just post it in the, I guess, events chat. Reverse dark mode. I like the light mode. I'm weird.
I actually like light mode.
And do you have Node installed? Okay, cool. So, anyways, turning to this, I'm just gonna copy and paste this function definition. I think I missed some stuff, but it's called total. Cool. We're gonna call this parse data 2, just be distinct from this one. We're gonna move this one eventually though. So the first thing we're gonna do is this this array, this for loop rather, basically goes through the data array and it finds all the stuff that is not a number using the isNum regex, and it removes it. So instead of doing that, we're going to do something like this. Where we go data equals data dot filter, and then filter is a unique function in that it takes an anonymous function. So first I'll explain what an anonymous function is really quick. So an anonymous function is just a function that doesn't have a name, and it can also be called a lambda. So each language has like their own kind of syntax for it, and most modern languages support first-class functions, meaning functions you can pass as arguments. So anyways, in JavaScript, you can define a lambda using this syntax where you do something like these braces, this arrow, and then you do the body of the function over here. You can do it in brackets, or you can just, if it is just a one-liner, you can just remove the brackets and just end it with a semicolon. So if we wanted to make like a function, anonymous function that doubles the amount of a number, we would do like n for number and then n times 2. And then if we wanted to if we wanted to give this anonymous function a name, we could do something like const double equals. And this kind of looks weird, but it's actually really idiomatic in JavaScript nowadays to do stuff like this, weirdly. But so that's what an anonymous function is. So, and then we can use these in tandem with this filter function. So instead of writing this, we can do, so we're taking a string, or I'll do this, and I'll just copy and paste this over here and replace this with the string, like so. And just to make sure we are doing everything, additional parentheses there. So everything's all good. I'll copy, paste. That, and so they both work the same still, so we're good. So what filter's doing is it's taking every single piece of data from this array and it's feeding it into this anonymous function. And then if this anonymous function returns true, then it keeps that value in the array. If it returns false, then it removes it. So in this case, it's taking in each string from this data array, and if it passes this regular expression, which makes sure that all the values are numeric, so it's an integer, then it returns true. So only integer strings will remain in the data array. So moving on to the next one over here, this for loop. This for loop is just looping through all the values and turning them from strings into integers. So to replace this one, we can use map. So we can do data equals data dot map, and we're going to pass it another anonymous function. You can also, in JavaScript, if your anonymous function just takes exactly one argument, you can remove the parentheses. So you could do like string dot parse int, which is kind of weird. I kind of don't like that. For exactly one argument, you don't need the parentheses in JavaScript, but I don't know, whatever. It's just how it is. You can remove that. And then still golden. And lastly, this loop, it has a total and loops through all the values in the array and multiplies them all together, basically, using this total. It's like an accumulated value. So instead of doing that, we can use reduce. So we can say like total equals data dot reduce. And reduce takes an anonymous function with two arguments, one of them being the accumulator, meaning basically there's like this one value that accumulates over time, and as it's passed along, it performs operations with the next like value in the array, and then we'll just say like n for next or something, and that's just going to do accumulator times n. So, and I need to do a let here. Too many parentheses. And we're golden. Okay, and now we have this very concise function, but we can make it even better. So you can see we're using this data variable and we're assigning it a bunch of times, but we don't actually need to do that. We can do something like this, remove that data, and instead of and we can do like that, and then we can go like this, and we can move this up to here. Now, voila, we have a one-liner. It's beautiful. But really, if you're actually like, this kind of looks cool to show off, be like, I can do this in one line. But if you actually like are writing code, you probably want to split these up onto multiple lines, like this. Even though technically it's still it functions as if it was one line, but for readability's sake, you want to split up into multiple lines. And you can do this because this is each one of these is returning an array, and then these use an array for their special functionality. So yeah, and if we compare this to this original parse data function, I think this one's a lot more clear as to what's going on, because we can see even if we ignore the bodies of these functions or the arguments being passed in, if we just look at filter, map, and reduce, we know, okay, this function is removing a bunch of stuff from this array, then it's going to transform the values in this array and then use those values to create some final result. And in addition to being more clear, I think it's also better because it reduces complexity. Because for each of these for loops, you're introducing a new variable that you have to kind of think about. And in the scope of these, it's pretty easy to think about, since you can see that I is not really going to change much, but it still adds a little bit of complexity that you have to think about. And in general, it's best if you're trying to do kind of like functional programming in JavaScript, every time you see let or var, you should cringe just a little, because that's adding mutability in, and you ideally want to have as little mutability as possible to basically to reduce complexity and reduce the amount of potential errors that could occur. So yeah, any questions?
On the map, you really need to make an anonymous function there, or you can just parse it directly?
JavaScript is a very strange language, Colin. I remember testing this, and I think you can with the parse it, but I know you can't just do isNum test, which you can in some other languages. Yeah, okay, you can't do that.
That's weird.
JavaScript is it is what it is. In JavaScript, you usually want to use the anonymous function, even if you think you can get away with just doing one thing. I don't know. I think what's going on is map, if you do something like this, then it it gives you the value and then also the index. So it might be passing the index into parse int, and then that does some weird thing. But in most languages, you could get away with just doing parse int. So yeah, that's that. And then I have some already completed like versions of the same function in 3 other languages, ascending in their quality. So we're starting with so we're starting with Python, and we can see I have 2 different parse data functions. So first off, this is how you do a lambda in Python with the lambda keyword. Then you do the arguments over here, and after this colon, you do the body. You cannot do multi-line lambdas in Python because Python is weird and annoying, as is JavaScript. But regardless, so this, and just to prove that these work, I'll do 3. Yeah. So the first thing is the double, which just doubles 4. So over here, we can see the same thing. We do filter, and we map, and then we reduce. You have to get reduced from func tools. And as Colin said, for the int parsing in Python, you can just pass int, since the int function like works like this. And annoyingly in Python, they chose to do it where instead of using like the dot like method syntax, you have to like wrap it around, so you get these weird cascading things, and it looks kind of ugly. An alternative way to do it in Python is to use list comprehensions, which could really use its own byte session or tech talk. But you can basically loop through all the elements in a list and like return a new list like so. So this is looking at all the elements in the data list, and if it's numeric, then it returns the int version of that string. And then I have product imported from NumPy instead of using reduce, so that just gets the product for us. So that's how you would do something like this in Python. And then in Ruby, this is how you do a lambda with these like brackets and these vertical bars. And here's like one way of doing the parse data, where you do a filter and you use the regular expression, and then you do the 2i, and then you multiply. But because Ruby's it leans more into kind of functional stuff than Python does, you can do this thing with this ampersand and the colon, so you can do 2i and then multiplication, which is pretty cool. So this is basically, instead of doing dot 2i, you can do this, and then it basically takes in the argument implicitly and does the dot stuff. And since multiplication is actually a method of integers in Ruby, you can do this as well, which is cool. And then lastly, we're actually going to do an actual functional programming language, Haskell. So in Haskell, lambdas are defined with this /. So if we double, yeah. But we can also like redefine it to be either like this, or if we want to be really crazy, we can do something like this, where we remove the argument altogether. And this is like called point-free programming, where you don't have the actual argument in the listing. So basically this is like, it's this double is taking this multiplication function, and it's currying it, so it's giving its first argument, because normally multiplication would do like int to int, and then returns an int, like so. But in this case, since we're giving it the first argument, it returns a function that's just int to n. It's pretty cool. We can see we have the parse data functions down over here. So in this case, it's going to filter these strings by using the all function, which is going to look at the string, and it's going to see if it's all of them are digits, basically. And it's going to read those into integers, and then it's going to use this full L function. And that's basically reduce in Haskell. And then another way you could do it is using maybe. So read maybe it's kind of for another talk about like maybe and like monads and stuff. But it basically tries to read a value, and if it can't, then it returns nothing, and if it can, it returns just in the value. And map maybe just takes all the just values and puts them into a list, and then product does what you would expect product to do. So yeah, that's. Oh yeah, and I was gonna say Haskell gets a bad reputation for being complicated, and people are like, "Oh, Python's so simple," but if we can compare these two, I think compare this function over here, I'll just copy and paste it over here, to this up here, or no, I won't. But if you compare this one to this one's a lot simpler. I mean, this is like, it's just 3 words, whereas this, it's got all this wacky stuff. So, Haskell wins again. Yeah. Yeah, any closing questions or anything? Okay.